Okay. Let me finish this example question. And here. Okay. The solution. Cholesterol level of patients who had a heart attack. The X1, X2 cholesterol level of health adults, and the average one or the mean cholesterol level of patients who had a heart attack. Cholesterol level for health individuals. Okay, and the normal hypothesis will be non-hypothesis. The average is equal, or the mean 1 minus mean 2 is equal to 0. That's okay. Then the alpha level is 0.01. That's okay. A random number sample of 28 cholesterol level from patients, that's 1. And random sample from 30 cholesterol level of health individual, that's okay. And you can do the calculation like this. Patients who had a heart attacks get a figure 1 here. And cholesterol level of heart attack patients after the kind of box plot of like this. You can see the mean and the maximum, the minimum, and the different percentile, 25 and 75 percentile here. Okay, then is a normal Q plot like this. It's a little bit complicated. Okay, we just switch to the conclusion. Simple statistic. The average of first one 252, the other is 193, and the standard deviation is 47. The other one is 22.3, as we as we got the calculation like this, and then we can see the number here. Then after the calculation, see the formula is really ugly, and you don't need to memorize those formula because it's really ugly. And get a p-value. The p-value is a different way to get different p-value, but the common point is the p-value is very, very small. Thus, it rejects the non-hypothesis. And these authors also use the different Welch 2 sample t-test, a little bit different calculation to do the t-test, and get a 95% interval like this. Okay, then we can do the next. I love the next example here. Example 9.3.3 hypothesis test for 2 means. And here, the amount of sodium in beef hot dogs was measured. In addition, the amount of sodium in poultry hot dog was also measured. Okay, and here is the source of the information. The data is in example 9.3.2. The table is here. Is there enough evidence to show that beef has less sodium on average than poultry hot dogs? Use 5% level of significance. Again, I think this kind of food example is friendly for us. And the first column, sodium beef hot dogs, the average sodium is like this. And the hot dogs are made of poultry, like chicken, like duck, and you can see the sodium level is like this. And the question asks us, is there enough evidence to show the beef has less sodium on average than poultry hot dogs? Okay, again, let me try. Copy this link, copy this. Copy. And go to the let me have different. Oh, sorry. Okay, and now I got the information here, and the first column here, that is in beef. I can use this. And the second column here, can use in light purple. Okay, and the same. Okay, and this time I suggest you to use different online applications. You don't need to calculate the mean and standard deviation by yourself. So I try to use different samples. Okay, then you can go to, for example, you can check the syllabus. The syllabus here. T-test calculator. I love this one. I love this one. Okay, and now we have the information here. So here we got it. Okay. I move it a little bit to the right. Okay, then I love this calculator. Now I enter or paste up to 2,000 rows. Oh, sorry, let me. Oh, come on. Let me adjust the size of this. Okay. And enlarge the size here. And use unpaired t-test. Use the unpaired t-test. Here, group 1, that is beef. The second group is poultry. Okay, and the information here, I just select and copy. Here, the second group, select Control C to copy, Control V to paste. Okay, after I finish this part, I can click Calculate now. Okay, then we can have some information here. The two-tiered p-value equals 0.1015, not reach the 0.05. By conventional criteria, this difference is considered to be not significantly significant. Okay. Then the mean of the beef is about -49. 95% confidence interval is different from that like this. And t-value sometimes is not important for us. And degree of freedom 38. Review the mean of the first sodium level 401, poultry 450, and standard deviation 102. The other is 81. The sample number is 20. Okay, please do this part. You can have a couple of minutes to run this part. Again, you can go to Actually, you can go to my website or you can go to the example 9 here. The textbook 9.3.3, you can copy and paste the information here to your Google spreadsheet here. Then this time you don't need to calculate the mean and standard deviation by yourself. You can use the website application. Okay, and in the end, I expect to see you can get the information like this. And done this one, like this. Okay, you can do it now. Please do me a favor, if you finish this part, please copy and paste the screenshot to your website. Thanks. About the final exam, I will give you some information similar to this format, and you can download the information from my website. And I think this part is important, so I will prepare maybe at least 2 questions about the t-test here. And I may also create some examples that you need to calculate the mean, the standard deviation, and some other information. Okay, and I'm going to share this website. Okay, I'm going to share this information to our online group. Okay. Okay, I think I can put it here. Okay, then we can go to the next problem here. Not this one, not this one. Okay. And now I'm going to play the video here, and
Department at the University of North Carolina at Chapel Hill. Today we're going to be talking about the normal distribution. This is part one of a handful of stat quests on this distribution because it's so darn important. Today, let's just start with the basics. Chances are you've seen a normal or Gaussian distribution before. It's also called a bell-shaped curve because it's a symmetrical curve that, wait for it, looks like a bell. In this example, the curve represents human height measurements. People can be short, average, or tall, or anywhere in between. The y-axis represents the relative probability of
from this diagram, we can see the bell shape of the normal distribution curve, and this is the most important curve. But just remember, I have a question before I start to explain this, and you know that. I think I can stop here. Okay, and here is the website. Here is the website. Let me tell you from Wikipedia. I know it's a little bit ugly here, and mu, the micro mu here, it means the average. So if the distribution is symmetric and very beautiful, you can see the highest point, the climax here, is the largest number in the y-axis, and here is corresponding to the average here. And you need to memorize one thing: when the mean plus 1 sigma is the population standard deviation. And you can see the number 34.1% on the dark blue area in the right side. And next is 13.6%, and the others. From the left side, 31.1%, 13.6% is here, and it means if your sample, your population, or your measurement is fitting the normal distribution, and the mean is on the center, plus 1 standard deviation, minus 1 standard deviation. Here is close to 68% of the whole population in this one. Okay, you need to remember this number. Close to 68% in the center part, the dark blue area is about but close to 68%. What does it mean? It means your sample mean is in the center and plus 1 standard deviation, minus 1 standard deviation. Almost, I can say that 95% of your samples are centered from this area. If now a student who has the height about 190 centimeter, very tall, I'm a middle guy, a very tall guy come into our classroom, we can believe the height in Taiwan is unusual because 190 is very tall, and the gentleman's height could be close to this part. And for ladies, maybe a lady
assume there is a lady in our group and her height is 180 centimeter. Wow, 180 is taller than me, and it is unusual. The lady's height is not on the center of the normal distribution. I believe it could be here. It could be here. Okay, and if a male student come to our classroom, his height is 165, maybe a little bit lower than average, but still in the center of the big area. But if a lady, her height is about 160 centimeter, I believe it's close to the average. If a gentleman, his height is 150 is, I think, is a little bit short, and his height will be close to the left end. And this is the normal distribution. Is it okay for you here? Okay, and go back to the video.
Observing someone who is really short or really tall or who has an average height. For example, it's relatively rare to see someone who is super short, so the bell-shaped curve is relatively low in this part of the graph. But it's quite common to see someone who is close to the average height, so the bell-shaped curve is very tall in this region. And it's relatively rare to see someone who is really tall, so again, the bell-shaped curve is relatively low in this region. Here are two normal distributions of the height of male humans when born and as adults. This is the distribution for the babies, and this is the distribution for the adults.
I love those diagrams because the baby, the difference is small, but after they become adults, the difference is larger than when they were baby. I love these diagrams.
The average baby height is 20 inches. The average adult height is 70 inches. Normal distributions are always centered on the average value. Just by looking at the graph, we can tell there is a high probability that a newborn baby will be between 19 and 21 inches tall. In contrast, adults are between 60 and 80 inches tall. You may have noticed that the curve for babies is way tall compared to the curve for adults. This is because there are many more possibilities for adult height than for babies. The more options there are for height, the less likely any specific measurement will be one of them. The width of the curve is defined by the standard deviation. We can tell just by looking at the curves that babies have a relatively small standard deviation compared to adults. The standard deviation for babies is 0.6. The standard deviation for adults is 4. Knowing the standard deviation is helpful because normal curves are drawn such that 95% of the measurements fall between plus or minus 2 standard deviations around the mean.
Okay, and here, another important information here about the 95 measure of the population or the samples plus minus 2 standard deviation. Okay, that means switch to here. Again, watch this bear type. In the center, when we have a mean plus 1 standard deviation, plus 2 standard deviation, this mean minus 1 standard deviation, minus 2 standard deviation, and almost 95, close to 95% of the samples are collected from this area. Outside, we can say this tail, the right tail, the left tail, and those tails are very rare. Okay, then you can read this, watch it, and put your focus on this diagram. Okay, because I think this normal distribution, this diagram is the most important diagram in our study. But I need to say one thing. If you roll a die or two dice, the kind of distribution is not a normal distribution because one die has 6 numbers, 6 sides, 6 area of that, and it's impossible to get the normal distribution because it's even distribution. The probability to come with 1, 2, 3, 4, 5, 6 points, they are equal. They are equal. So the distribution is not like a bell shape. It's a rectangle shape. Rectangle shape. Okay, then go back to the video.
This means that 95% of the baby measurements fall between 20 plus or minus 1.2 inches. And 95% of the adult measurements fall between 70 plus or minus 8 inches. To draw a normal distribution, you need to know 1. The average measurement. This tells you where the center of the curve goes. 2. The standard deviation of the measurements. This tells you how wide the curve should be. And the width of the curve determines how tall it is. The wider the curve, the shorter.
Okay, again. We assume the total area. What is the area? Underneath the curve, close to the x-axis, that is the area. And the standard deviation of measurements, this tells you how wide the curve should be. And the width of the curve determines how tall it is. Sure, the wider the curve, like the blue lines, the shorter. Okay, again, when we watch this, the distribution is wider and the height of the center is lower. On the baby, the green line, the case, the distribution is closer, very narrow. So we can see the average there is very high. In other words, the height in baby, they are not significantly different. They are very close to 19 inch to 21 inch, this level. Okay.
The narrower the curve, the taller. The curves then tell us that there is a high probability of measuring a newborn baby boy within plus or minus 1.2 inches of the mean. And there's a low probability of measuring a man within plus or minus 1.2 inches of the mean. Lots of things are normally distributed. We've been talking about height, but there's also weight, commuting times, and many more things. The normal distribution is kind of magical in that we see it a lot in nature. But there's a reason for that, and that reason makes it super useful for statistics as well. Spoiler alert, it's called the central limit theorem. I'm already working on a whole stat quest on the central limit theorem, so that's something we can all look forward to. Hooray! We've made it to the...
Okay. And again, okay, let me. Okay, about the normal distribution, before I go to the textbook, I think I prefer to use the information from Wikipedia because it's beautiful and friendly here. And here, oh no. Okay, can you see the equation here? The function is equal to, when I was a PhD student, I tried to use the plot software to plot this function. Then I failed because it's too complicated. I don't know how to plot it, but I don't know how the scientists find this kind of curve about 200 or 300 years ago. And the Gauss, he discovered and determined the curve like this. But for us, we don't need to be a scientist. We just need to know, okay, again, the average is in the center, the highest point, and the plus minus 1, 2 standard deviation, minus 2, like this. Okay, then we can go to the this one. So okay, and I prefer to use the no, not this one. Okay. And now let me show you the information like this. I placed some useful website like this. Okay, some online applications, and they are really powerful, and you don't need to calculate the details because I never successfully did it. So don't worry about it. And normal distribution calculated like this. I will try this. I'll try this. Okay, like this one. Here, okay. For example, if I have a number, here, the mean. Okay, I can use the information like this. Okay, I can use the example from previous calculation. The cholesterol level from patients here, the average is 253.9. Standard deviation is 47.7. Okay, then we can see above, below, that's okay. Then we can see the cholesterol in the center, that is 253.9, because here, and plus 1 standard deviation, that is 47.7, will be here. That 301.6, plus 2 standard deviation, that will be 349.3, like this. So you can see here. Okay, let me have my tool here. Okay, here from the average 253.9 is the highest point, the peak of the top, on the top, and plus 1 standard deviation, the cholesterol level here, plus 2 standard deviation, the cholesterol level is here. What does it mean here? The probability, you can find the corresponding y-axis here. It means the probability is much lower, but the probability to get the 253, the average, the probability is highest one here. Again, so I use the information here. Okay, oh, no wonder 28 patients with heart attack, their cholesterol level, if with the normal distribution, then I can understand 86% of the patients, their cholesterol level will become 206. Sorry, it will between 206 and 301, this area. And 95% of the patients, their cholesterol level will between 158 and 349 here. Get it? So, okay, then please use this website. Okay, I'll copy and paste this website. You can find the website here from my syllabus. Or you can do it, and please plot the information here. Okay, you can do it. You know, whenever a PhD student, we have no such software to draw the bear shape. And now the online applications, especially on your cell phone, there are a lot of apps you can use. And I expect you will get the normal distribution curve like this. Okay, you can try this. After you finish this part, please take a screenshot. And copy paste on your website, your blogger. In the final exam, I may ask you, I will give you a data set with the mean and the standard deviation. I will ask you to draw the bear shape, the normal distribution curve, and that will be one of the final exam questions. Maybe questions. Next I will tell you, actually 95% of the area, that is not exact plus minus 2 standard deviation. That is very close. That is plus 1.96 standard deviation. Not the 0.2, but very close.